Hello, art students. Today we're going to do a derivative calculation of cell state in LSTM. So you will notice B and A here. So B is the same as W matrix in the original LSTM. So this is a transformation of our input matrix Xn. And A is same as U matrix of the original LSTM. So this is a transform of the previous cell state. I would denote as C tilde n minus 1. Okay, now we're good to go. And G is the activation function. And you will notice atom R product, you can treat this just as element wise multiplication. Okay, now let's define chronicle delta JK, which gives us 1 if J is equal to K and 0 otherwise. Now let's define C tilde J n, which is the jth element of G, B, C, the current state of Xn, the input state, plus AC, C tilde n minus 1. This is a previous state. So now we can express the partial derivative of C tilde Jn with respect to the previous state, Ck, I would say Ck with n minus 1. Now, in order to define this, we need to define the candidate state of Cj, C tilde J, which is equal to Fj of n, dot product of Cj n minus 1, the previous state, plus the input gate, Ijn, dot product with the activation function G, BC, the current state, Xn, plus C tilde of the previous state, n minus 1. Now we can apply the chain rule with everything. So this is the same as I'll break it down with chain rule. So this is a partial derivative of the candidate state of K, the previous state, n minus 1, multiplied by everything here. Right? Okay. And we can break this even further into individual terms. So I would define it again. This one. So this one is actually equal to the partial derivative of Fjn, the current state, with respect to the candidate state of the previous state, multiplied by Cj of the previous state, plus Fj n minus 1, n, with respect to Cj n minus 1, with respect to the candidate state Ck n minus 1, plus the input gate Ij, which we defined earlier, over with respect to C tilde K n minus 1. And multiplied by, this is just the multiplication of, so you might have noticed that this Cj respect to the candidate state of Ck, this is just the chronicle delta Jk that we defined earlier, this one. So the partial derivative of the sigmoid and the hyperbolic tangent functions are need to be calculated next. So let's next calculate the intermediate derivatives. So the partial derivative of the forget gate n with respect to the candidate state Ck of the previous state, Fj here. This depends on the previous state, right? So through the sigmoid function, so we can just actually apply the sigmoid function here. So let's define it first, actually. So Fjn is the sigmoid function of Bf xn plus Af C tilde x n minus 1. And thus, this thing over here is the derivative of the sigmoid function, Bf xn plus, I'll say everything. So f c tilde This is not right. F A F C prime F C C tilde n minus 1 and multiply by AF IJ, the jkth entry of the matrix. All right, so now, so this was the first thing that we had to do. And the second thing, we calculate input gate IJN with respect to the candidate state C tilde CK n minus 1. And the way is pretty similar, so we can redefine IJN as the sigmoid of BI this time, XN plus AI, the cell state, n minus 1. And we can write this as sigmoid function of the derivative of the sigmoid function, BI X N plus AI C tilde of C minus 1 and multiplied by AI, the jkth entry of AI. Now the last step is to calculate the G, the activation function itself, with BC, the current state, the X N plus AC C tilde n minus 1 with respect to this candidate function C tilde K n minus 1. Then now this is equal to is actually the hyperbolic tangent of BC XN plus AC CD tilde n minus 1, right? So we can just get the derivative of this. So derivative of the activation function G, and this everything stays the same. So everything stays the same here, plus AC C tilde n minus 1 multiplied by the jkth entry of the matrix C. Now let's combine everything, these derivatives, into main equation that we wanted to solve. So this one, the partial derivative of Cjn with respect to Ck, the previous state n minus 1. This is what we try to solve initially. So we can combine everything. Let's see if this makes sense. So derivative of the activation function, the derivative of the sigmoid function, B F Xn, B of Xn plus AF C tilde n minus 1 plus, sorry, multiplication. We multiply the the jkth entry of C. We multiply by the jkth entry of matrix F, the four-gate gate, multiplied by Cj n minus 1 plus Fjn. And this is a chronicle delta we defined earlier to, instead of this Cj with respect to the candidate state of K. So this is a chronicle delta. And plus the derivative of the sigmoid function, BI X N, right? And plus AI of the candidate state here. Now let's redefine this as JK of N and the chronicle delta. We bring everything here, the chronicle delta of JK plus CJ here, this one, this place, we're distributing it. So CN, CJ n minus 1, FJ, the four-gate gate of J, N, and multiplied by N minus FJ, and multiply by 1 minus Fjn. This is the result from the derivative of the sigmoid function. So I'll just write it like this. And then multiply by the jkth entry of F plus the cell state C, the candidate state of C, N, plus the input state, Jn. And then same, 1 minus Ijn. So this is the result of the derivative of the sigmoid function. And I of jk plus ijn, ijn, g plus ij, n, g tilde, the derivative of bc xn plus ac c tilde, the candidate state of the previous state, n minus 1 multiplied by the jkth entry of C matrix, AC. Thanks for watching this video. And if you have any questions, please drop them in the chat. Thank you.